Hi everybody, in this video we're going to talk about the intermediate value theorem for continuous functions. This is something you may have heard of before. It's a topic that might be covered in a pre-calculus or maybe even an algebra class. Now we will see this again later in the semester, but we're going to introduce or remind you of it in this section. So, theorem. The intermediate value theorem for continuous functions. The continuous requirement is extremely important for the intermediate value theorem, as you're going to see in a minute. So I'm going to read the statement for the theorem, and then we're going to talk about what it means. If f is a continuous function, remember what continuous means. You can trace the curve without picking up your pencil on a closed interval from a to b. So it starts at a, ends at b. If y0 is any value between f of a and f of b, then y0 equals f of c for some c in a and b. All right, what is this theorem telling us? That's what we need to discuss. So let's suppose you have 2 points. 1 point here at A and 1 point here at B. What happens outside of that, I really don't care. It could be anything happening with the function. All I care about is from A to B, what's happening. From A to B, I have a function value of f of A, and then I have a function value of f of B. So those are the y values, the function values. Make sure we understand that part. So if f is a continuous function, to get from literally point A to point B, what does my curve have to do? If f is a continuous function, then my curve has to connect these 2 points with one continuous curve. So I don't know exactly what my curve is doing, but I know because it's continuous that it has to have one smooth curve from A to B. The blue is one example, the green is another. I can make a whole bunch of different curves. I can make almost a straight line here. I can make a parabola. But no matter what, because it's continuous, it has to be one curve that connects A to B without picking up your pencil. Now, if we know that we have a continuous function connecting these 2 points, what does that tell us about the function here? The intermediate value theorem says, if this is happening, if you have a continuous function connecting A to B, then you have to be able to pick any point between f of A and f of B. So they pick y0. For any y0 between f of A and f of B, there has to be a corresponding point on the curve. You cannot go from f of A at point A to f of B at point B without crossing every single y value in between. All right, let me erase this and try make sure everybody understands. Explain it one more time. To get from A to B, no matter what continuous curve you draw, it will have to cover every single y value from f of A to f of B. Isn't that cool? So, summary here. A function is said to have the intermediate value property if, whenever it takes on 2 values, f of A and f of B, it also takes on all the values in between f of A and f of B. Now, how are we going to use it? Well, what you probably saw in an algebra or pre-calculus course is this particular example, such as this one. If we know that f of x is a continuous function which has values from equal to -10 and 13. So envision here, if I were to draw a graph, we have a point x1, and we have an x value of x2. At x1, our function value is -10, so it's somewhere down here at -10. At x2, we have positive 13, so we're somewhere up here at 13. This is the y-axis and the x-axis. Now, if we know that f of x is continuous, that means these 2 points have to be connected by one continuous curve. What additional information do we know about f using the intermediate value property? What can you say for sure about this function? According to by the intermediate value theorem, f of x has values of every number from -10 to 13. The most interesting one, and the one that you've probably heard of before, is the fact that f of x must equal 0 for some x. between x1 and x2. Oh yeah, I should have said that here. By intermediate value theorem, f of x has values of every number from -10 to 13 from x1 to x2. All right, so that's kind of cool. Basically, we're saying here the function crosses the x-axis. And again, we're going to see this again on the last unit of this course, so it'll come back, but just wanted to bring it back and remind you of this in this section. So again, study hard, make sure you practice, and I'll see you in the next video.